Welcome back to Megastruction. Florida is in the middle of a makeover so big it doesn't feel real. 5 major builds, 1 shared goal, and a price tag that lands around $27 billion. This isn't just about bigger skylines. It's about buildings that have to keep working when everything else fails. Offices that can stay online through hurricane season. Hospitals that can take a surge of patients without collapsing under the weight of heat, humidity, and nonstop growth. And public facilities that can't afford to go dark even when the grid does. Here's the twist. In Florida, the land fights back. The water table sits high, salt air eats metal, wind codes punish tall towers, and every basement decision turns into a flooding decision. So these 5 projects don't just rise, they're engineered to survive. This first project goes up in Brickell, where new towers pop up all the time. But this one is different because it's not just trying to look expensive. It's trying to stay usable when Miami gets hit. At street level, the design already gives it away. The main entrance sits higher than you'd expect, and the lower floors are treated like a rough zone, built with materials that can take water, take sand, take a beating, and still be cleaned up fast. It's the kind of planning you only do when you've seen what storms can do to buildings that pretend flooding is rare. The real headache is underground. Brickell has a high water table, so the moment crews start digging, the site wants to fill up. Pumps run non-stop. Soil has to be stabilized. Then they drive deep piles down to something solid, because a tower this tall can't rely on soft ground near the coast. After that comes a thick concrete mat that ties the whole base together. It's slow, it's heavy, and every step gets inspected like the building is already on the line. Inside, the money goes into the boring stuff that matters. Power isn't just one feed and a generator. Just in case. It's layered. Multiple feeds, equipment placed above flood risk, and backup generation sized for long outages. Cooling is treated the same way, because in Miami, you can't keep a building running without it, especially if it's packed with servers and dense office floors. Elevators are split into zones so the building doesn't choke during rush hour. Some routes are protected for emergencies because getting people out of a super tall isn't a simple stairwell problem. Even the glass isn't normal. The facade is built to resist hurricane pressure, with seals and framing meant to stay tight when the wind is pushing hard. So yes, it's an office tower, but it's also a storm-proof business bunker. Before we continue with the video and my further explanation about Florida's $27 billion makeover, I want to ask for your help. I'm trying to reach 1,000 subs by the end of the month, so I'd really appreciate it if you would subscribe and help me out. Okay, let's continue. Orlando's project is a different kind of big. It's not about a skyline flex, it's about capacity. How many people can be treated, how fast, and how safely. This tower is basically a vertical hospital city. Hundreds of beds, dozens of operating rooms, whole floors dedicated to surgery, imaging, intensive care, and recovery. The building has to run 24/7, and it has to feel calm while it's doing it. That's harder than it sounds when you're stacking the noisiest, most mechanical parts of a hospital into one tight footprint. The cost comes from what you don't see. Every floor is packed with systems, medical gases, backup power, filtered air, sterile corridors, and water lines that can't fail. The air handling alone becomes a monster. Hospitals don't just cool air, they control pressure and cleanliness. Some rooms must push air out, others must keep air in. That means huge ductwork, heavy equipment, and constant monitoring. Then there's the surgery side. Modern operating rooms aren't just bright rooms with tools. They're built for robotics, real-time imaging, and teams that need space to move fast. The tower also has to connect smoothly to emergency intake, labs, pharmacy, and sterile processing. If that circulation is wrong, the building looks fine but works badly, and in healthcare, works badly shows up as delays, infections, and people waiting too long. Construction is its own challenge because hospitals don't get to pause. They can't shut down the campus for years, so the build has to be staged, with strict noise and vibration limits near sensitive areas and safety rules that feel closer to aviation than construction. And because Florida storms are part of the schedule, the tower is built to keep functioning through outages, redundant power feeds, generator capacity that can carry critical loads, and protected spaces for the equipment that keeps patients alive. This isn't just a new building, it's a promise that Orlando can handle what's coming next. The third project is built for the days Florida doesn't like to talk about. The pileups on the highway, the holiday weekends when the ER is already full, the storm that knocks out power for half a county and suddenly every hospital bed is spoken for. This is a trauma tower and research center built as one connected spine. On one end, emergency and critical care, fast elevators, direct ambulance routes, trauma bays laid out so teams can work without bumping into each other. On the other end, labs, imaging, and research floors that feed new treatments back into the hospital instead of sitting across town in a separate building. The tricky part is making it all work together without slowing down the life or death side. Trauma doesn't wait for a badge scan or a long hallway, so the building is planned around short routes and clear separation. Patients move one way, supplies move another, waste moves another. If those paths mix, the whole place becomes a problem. Then there's staffing. This project quietly admits something everyone knows. You can build a beautiful hospital and still struggle if nurses and techs can't afford to live nearby. So the plan includes nearby housing blocks for staff, simple, durable buildings meant to keep shifts filled and turnover down. On the engineering side, it's built like a bunker that looks like a campus. Critical equipment is protected from flooding. Generators and fuel storage are sized for long outages. Mechanical systems are redundant because trauma care can't try again later. It's not the tallest tower in the story, but it might be the most serious one. Jacksonville's project is all about speed. Not speed for drivers or commuters, speed for patients. The goal is simple: stop the waiting from becoming the danger. This expansion reshapes the emergency department into a bigger, cleaner, more organized machine. More treatment rooms, more imaging right next to intake, faster paths to surgery, ICU, or discharge. The layout is designed so ambulances don't get stuck in a mess of traffic and doors. They pull in, offload, and teams are already moving. The hard part is building it without breaking the hospital that's already running. You can't just close the ER for construction, so crews build in phases: temporary entrances, rerouted hallways, sealed work zones, and strict infection control rules. Every loud cut, every vibration, every dust risk has a plan attached to it. And then Jacksonville adds the Florida layer. The building has to stay open when storms hit. That means protected electrical rooms, backup, generation that can carry critical equipment, and systems placed where flooding can't easily take them out. It's not a flashy project from far away, but on the inside, it changes the clock. This one doesn't come with a single skyline photo because it isn't one building. It's dozens of upgrades spread across the state. Clinics, public health hubs, smaller hospitals, and emergency command centers that are supposed to keep running when everything else is struggling. It's also the easiest project to underestimate. People hear retrofit and picture a quick renovation. In reality, it's like doing surgery on buildings that still have to breathe. A lot of the work is unglamorous but critical. Moving electrical rooms out of basements, raising generators, sealing doors, reinforcing roofs, replacing old windows with hurricane-rated systems, and upgrading cooling so equipment doesn't overheat during outages. Some sites add microgrid-ready switchgear so they can isolate from the main grid and still operate on local power. The biggest challenge is the domino effect. You replace one major system and suddenly the building has to meet newer codes everywhere it touches. A simple electrical upgrade becomes a fire protection upgrade. That becomes ceiling work. That becomes a whole floor shutdown you didn't plan for. And because it's spread out, the logistics turn brutal. Different contractors, different city permits, different timelines, different supply chains. One delayed part can stall an entire facility. It's not the most dramatic project, but when the next major storm hits, it might be the one that decides what stays open. Before we continue with the video and my further explanation about Florida's $27 billion makeover, I want to ask for your help. I'm trying to reach 1,000 subs by the end of the month, so I'd really appreciate it if you would subscribe and help me out. Okay, let's continue. So, that's the 5-project makeover. One super tall built like a bunker, one surgical tower built for nonstop volume, one trauma and research spine built for the worst days, one emergency expansion built to cut the waiting, and one statewide retrofit built to keep the lights on. $27 billion sounds insane until you remember what Florida is trying to do. It's not just adding buildings. It's trying to keep up with growth while building against heat, water, and storms that don't care about budgets. The real question is this: when the pressure hits, which of these projects actually performs?